Hi, good afternoon. I am Matt Ingenthron from Couchbase, and my colleague here is...
Daniel Templeton from Cloudera.
So I'm going to turn it over to Daniel, who's going to do the first few slides. This is the session on why Couchbase, every Couchbase deployment should be paired with Hadoop, and you'll find out why shortly.
Actually, everything should be paired with Hadoop.
And everything should be paired with Couchbase.
All right. All right. The framing for a lot of this talk is this notion of polyglot persistence, which you hear kicked around a lot. Right? Polyglot being someone that speaks multiple languages, or in this case, we're talking about multiple data sources, right? And persistence being making it hang around, right? As in data, stuff that you want to write and then maybe read again later, right? So in today's world, it's really hard to put all your data in one place, right? There are, if you go look across the landscape of SQL, NoSQL, new SQL, and whatever other SQL technologies that are out there, they each have their own little niches, their own little purposes, and it's really hard to find one that really does everything that you want. So you end up picking the best tool for the job, and then you've got 14 tools, right? So what do you do about that? And Hadoop is part of that answer, right? So kind of the motivation for why we're stuck where we are is a lot of the technologies were built in the olden days, right? When memory and disk space and even CPUs were constrained and we worried about stuff like that. You know, do you remember trying to fit things into 64K of RAM? Right? A lot of these models persisted much longer than they should have. And you know, having been an engineer on a project that started in the 90s and continued on into the 2010s, you just can't modify those things sufficiently enough to get that heritage out of them. You end up having to kind of rethink things. So Hadoop is one of those rethinkings. Oh, I think I might have dropped a slide in here, so that's okay. So what is Hadoop? Hadoop is buzzword compliant, right? It's NoSQL, it's unstructured, it's highly scalable, it's everything you ever wanted it to be, right? But what is it, right? Well, it's the big data operating system, right? But what is it, right? So let's start at the beginning and try and actually lay a foundation for what Hadoop is and why you should be just as thoroughly excited about it as I am. So think back to the simple days, right? You've got data, say it's a giant CSV file of something that you care about and you want to process it. You're going to go write a Perl script or a Python script, or you're going to go open it up in Excel, the dirty little secret of data science, right? Either way, you've got your data local to you, you've got your compute local to you, and you're operating on it kind of in a little closed box. And everything's simple, easy, it makes a lot of sense. What's the problem? One box doesn't scale. So now you've got lots of things you want to compute. What do? Well, you break it out, right? So you've got a compute tier and you've got a storage tier. Compute tier tends to be big because compute tier, you just throw more compute resources at it, and as long as you're not writing parallel applications, scales really well. Storage tier, however, you kind of keep constrained. You want it in one little box still because you want all the data to be the same data for all the nodes, right? When you start spreading your data, you start having problems, right? So what do you do when it keeps growing? Well, throw more compute at it. That's easy. Storage gets hard. You start vertically scaling and you start paying large red companies lots of money for extreme database things that can still be that single entity instance that doesn't get confused about multiple personalities of data running around on a network. But that's expensive and we don't like that. NoSQL to the rescue, right? So one of the cool things about NoSQL, all of these tools, Couchbase in particular, is it gives you the ability to just throw more nodes at the problem. So you get these small nodes, and you can kind of parallel the compute and the structure of the compute cluster with the storage cluster. Now that's great, but it gets even better, right? If you think about Hadoop, Hadoop actually is a different way of looking at it. Instead of saying, okay, let's divide this up and we put the compute over there and we put the storage over there and we scale them both independently and then they can each do their own little thing, Hadoop world says, no, we never separated them. Every node is compute and storage. There is only one cluster, right? And that has a few really interesting implications. So first of all, your data is processed in place, right? Your compute is resident with your data. When you go to calculate something, you don't take the data from the storage network, drag it over to your compute network, do your computation, and then drag the results back. You put your computation on the node where the data is, it does does whatever it does, and it leaves its results there. And you can then aggregate the results out of that data storage cloud, essentially, that is part of that cluster. That is where the scalability of Hadoop comes from in a large way. Right? That's what helps you do these massive computations and do them so much faster. You know, we talk about in comparison to a traditional EDW, if you have a query that takes seconds to run on EDW, it probably takes minutes to run on Hadoop. If you've got a query that takes days or weeks to run on EDW, it probably takes minutes to run on Hadoop, right? Because we're able to spread it out over that network, so when you get up to scale, we handle it very well. The architecture itself is very, very scalable for that reason, right? Yahoo has a cluster of 9,000 nodes, right? One cluster, 9,000 nodes, all cooperating, doing benchmarks mostly. But it's interesting to know that that's where your upper end is, which is pretty high. And the kind of the cool thing is that it's optimized. It was really built around junk, right? When Google and when Yahoo started banging on these technologies, they did it from the perspective of, we don't want to pay anything for our hardware, so we're going to scrounge stuff off the street, put together the cheapest junk we can find, and write the software to work around it. There's actually big chunks of Hadoop which are just dealing with the fact that your hardware is probably crap. Right? This has a distinct advantage, because now you can have 9,000 nodes of junk, which means you have lots and lots of capacity to store everything you ever thought of having in your cluster. Every little bit that's ever gone over the wire, store it, why not? It's cheap. And oh, by the way, you have compute that scales with that storage. So now all those web logs that you stuffed into some file system somewhere and then threw away after a month because you didn't know what to do with them, store them all, keep 10 years worth of data, it's great. Then you can analyze it and you can discover stuff that you never knew you didn't know, because you never were looking, right? So that's kind of the excitement of Hadoop. I call it the big data petri dish, right? Because you dump everything in there, and every once in a while you stir it a little, and you see what tries to climb out. And when something tries to climb out, you maybe move it off into some more nearline or online storage. One other point that's important to make on Hadoop, so that's kind of the motivation for Hadoop. That's why Hadoop's exciting. Now, why Hadoop's confusing is that Hadoop is actually a double-loaded term. So Hadoop means either MapReduce and HDFS, which is the original Hadoop, or Hadoop means all of this. Right? And you can see the Hadoop bestiary has some very clever names in there, like people were making fun of Oozie and Mahout and Zookeeper and all kinds of crazy stuff. Basically, what this amounts to is the big data operating system. Right? This is a set of components which let you, it's all kind of hung together by HDFS, which is your storage, and it lets you take a variety of different perspectives on that data for how you're going to process it. And we're going to look at a couple of those perspectives. Things we won't talk about later, so I'll mention now. Flume is all about streaming data. Right? Hive is basically an SQL interface to Hadoop. Mahout is machine learning algorithms pre-built for you, ready to go on Hadoop. HBase is a real-time key value store that uses the same data store as MapReduce and the others. So with that, I'm going to hand over to Matt and let him talk about some common use cases, and then we'll come back to the demo.
Thank you. So, so now that you've, I'm sure this morning you heard quite a bit about Couchbase. A number of you are probably already using Couchbase in either 1.8 or 2.0. But what you probably are really interested in is how do these things come together, and that's really the focus of this session. And so the best way for me to explain that is to talk about some very specific use cases. The first one I want to raise, and this is one that actually predates any of the Hadoop integration that Couchbase has done, working with Cloudera on a project called Scoop to make sure that we could work inside, extracting data, moving it over into Hadoop, and also putting it back over into Couchbase. Prior to that even, we'd been working with a number of customers, such as AOL is the large one that comes to mind on things like ad and offer targeting. Now this is kind of an interesting thing, because if you're, so quick show of hands, how many people here do ad targeting? Okay, a few. Okay.
How many are embarrassed to admit that you do add? No, okay.
Oh, one. So I'm going to give a very pedestrian definition of ad targeting. It's of course far more complicated, but it is useful for people to understand that, especially for those folks who do ad targeting. It's a really complex thing that you have to do. You can certainly look at bits and pieces of it and say they're simple, but with extremely tight service levels that they have to live within. For example, in this case, if say I'm AOL or I'm AdScale or I'm MediaMind or Chango, and I have that little box on the page, and I need to decide what am I going to display in that little box on the page. And the better I do at displaying that little box, the more revenue I am likely to get out of that. However, there's a service level associated with it. I have 40 milliseconds to respond with a decision. And 40 milliseconds is not a lot of time, and it's certainly not a lot of time to run some algorithms, look at a profile, or do a bunch of database queries, right? So the more time that you can, the quicker you can get the data you need, the more time you can spend on your algorithm. The more time you can spend on your algorithm, or the more time, the bigger the profile that you can work with, the higher the likelihood is that you're going to display something that's relevant that user is going to be able to pull up. So in the case of AOL advertising, but this use case applies to multiple different sort of scenarios. Really what they have is they have their ad platform that uses Couchbase as the operational store to get information out of when deciding what ad to display. Now Couchbase in that case is actually holding the profiles and the campaigns. So profiles of users, the ad campaigns that are underway at a particular point in time. Also, in the case of AOL advertising, they're actually putting events directly into Couchbase. So that means that they even update the user profile over the course of the day without doing a lot of the heavy lifting in a back-end analytics type system. Now, those events and where the profiles and campaigns come from, in AOL's case, is from Hadoop. So that means that there's in their environment, and in many of these environments, it's the big data petri dish, as Daniel mentioned. It's the situation where they keep all of that data about those users. And as the algorithms get better, as they find new ways to extract information from the already existing information they have about the user profiles, they can build, well, I shouldn't say user profiles, about events from users, they can build better user profiles and do so on a regular basis, and on even what they may call a real-time basis, which in some cases is batch. 4 hours is actually relatively real-time in the early days, and now they even go further where they keep some profile information online. So that's one use case, ad and offer targeting. Looking at the moving parts, again, the AOL deployment actually predated some of this technology, but just to look at the moving parts a little bit, you have a large number of users. The internet at large scale is hitting this ad targeting platform, and that is directly accessing typically a Couchbase server cluster. And this thing can, for small items, serve up small items. I don't know how many have actually benchmarked this. I have. A number of times. So for small items, things that fit in a packet, we can serve those across just gigabit Ethernet, flat gigabit Ethernet in about 250 microseconds or so. So that gives you another 39.75 millis to do whatever you need to do with it. Now, in most cases, the profile is actually much larger, so it's still a few milliseconds, and then you have a good 30-some milliseconds to figure out what you need to serve up and send that out. Now, those events are also hitting that Couchbase server cluster. And as we mentioned earlier, we have to take those events and turn them into a profile. So the way that you would do that in a combination of Couchbase and Hadoop deployment with Cloudera is you would use a tool called Scoop. Scoop is it technically stands for sequel to Hadoop. But oddly enough, the first certified connector was actually a NoSQL connector. It was ours. So we've leveraged Scoop as a way to move data from Couchbase to Hadoop. And then after you build a profile on the user, you may move that back over to Couchbase. So this is effectively the operational store, and Hadoop is effectively the big data petri dish. So. Now there is another aspect to this, and this is certainly true in the AOL case, that there are also flat logs that may come from the ad targeting, other parts of the ad targeting platform, and those also go into Hadoop, and that happens through Flume as a way of streaming data into that Hadoop system. But all of that combined data is used with their proprietary algorithms to understand what's happening with that data to know what to pull back to the operational store. Okay. One other discussion, because this is another set of common deployments, so content and other recommendation targeting. And if you look at this, it's actually pretty darn similar in that for the most part we have a situation where we need to make recommendations, especially content recommendations. If I'm on All Recipes is one example. I don't know for certain exactly how All Recipes uses Couchbase, but you're looking at a particular recipe. Maybe I want to recommend that person. I know they've searched for chicken and mango recently. Maybe they want to look at a chicken mango salad, or I don't know. I'm making that up now. but you're familiar with the idea. Recommendation targeting is not unlike ad targeting, and so it's something that we frequently want to be able to do. So you would be able to get that operational information directly out of Couchbase, but in many of those content sites, they also frequently are built around an existing CRM system or something along, or not CRM, sorry, content management system or something along those lines. And that means that a lot of that data may actually exist in a legacy relational database. So when you have that legacy relational database that is maybe serving up what the current content is or is involved in content workflow for what gets published to the site, you may need to take a combination of that, the events that may be streaming straight to Hadoop or through Flume to Hadoop or through Couchbase to Hadoop, take the combination and bring that back to that operational store. Couchbase is the operational store in order to make that recommendation targeting. So in this case, it's a very, in many ways, it's very similar. We have this content-driven site, and in order to keep up with those changing needs for users and the changing content and still provide relevant recommendations for them, we want to be able to analyze logs that are coming off of that site. We want to be able to analyze event data that may be recorded to Couchbase, and we want to be able to take our what's happening from the content system itself in this legacy RDBMS, pull all of that together into the big data petri dish, and come up with the profile information I may need in order to show relevant information to a user. Okay, we'll talk a little bit more about this. I'm going to turn this back over to Dan, who's going to set up a little bit of what we're going to talk about on the demo.
You like that term way too much, big data.
Big data.
Yeah. All right, so getting into what we're going to demo. So Matt mentioned Scoop as this kind of tool. So what I'm going to do is kind of set up what the technologies that are going into this demo are, and then I'll let Matt come back and actually show run the command lines. So what we've got, the demo is, it's two-node clusters. This works, again, both of these technologies, very scalable. We picked 2 nodes because we're cheap and don't want to spend more on VMs. What we're doing is scooping data, so back to the first use case, scooping data out of Couchbase into Hadoop, where the notion is that Couchbase has got the stuff that you're serving. Well, you don't necessarily want to have everything in there because you're not going to serve most of everything. You're only going to serve what's current and relevant. So the everything ends up in Hadoop. Right? So Hadoop has the long view. Hadoop's able to look at the whole of time and make ad recommendations based on what this person was doing the first couple of weeks after they were born. Right? This is as opposed to what are they doing in the last few minutes. So we do the analytics there in Hadoop, then we scoop the results back into Couchbase from Hadoop. And we're managing this workflow by a tool called Oozie that we were making fun of earlier. The naming in Hadoop, as one of our SEs likes to say, lacks adult supervision. So Oozie, I forget actually what Oozie means. Oozie is, I believe, a Hindi word, and it's something to do with elephant, like the saddle for the elephant, or the person who rides the elephant, or something or other like that. All right, so in any case, so what is this scoop thing? So again, just like I did with Hadoop, let's step back. Let's look at what you do know, and then let's bridge that into scoop based on what you now know about Hadoop. So when you do an ETL, right, it looks like storage on one end, storage on the other, something in the middle, sucks out of one hand, does some kind of massaging, usually to make the data formats line up, and then shoves it over to the other side, right? I mean, this is what Pentaho does day in, day out. So in Hadoop land, in Scoop land, remember, there is no other storage, right? We no longer split the compute and the storage, so the storage is local. So now we're only moving across the network once, right? And then we're just dropping onto disk. And oh, by the way, it's really, really scalable. So now you're sucking it out, dropping it onto your local disk massively in parallel. This ends up looking like one of two things, at least from the database's perspective. It's either a really high scalability data transfer, or it's a very effective DOS.
Denial of service for those who are not sure.
Thank you. I need subtitles. Yeah. So one thing to point out here is, right, we looked at ETL, right? Let's go back for the principle of it, right? ETL, we extracted, we transformed, we loaded. Here we extracted and we loaded. Where'd the transform go? Exactly, it's MapReduce. It's that your data is now local to the cluster. So in the ETL, you had to do the T between the E and the L because you had to get it while it was in flight, because otherwise you'd have to take it back into flight, do the transform, and dump it again, right? Because we compute where the data is, transform all you want, transform a half dozen times, do whatever, and there's all kinds of tools for doing it, right? I mean, this is what Hadoop is good at. And if you look at the use cases that Hadoop is in production with today, a lot of them are this sort of ELT kind of operation. So now something really interesting happens when you put Scoop and Couchbase together. They're both very scalable, very parallel sorts of things. And when you look at what Scoop does, right, Scoop's operating in parallel. It's one little scooplet. It's basically a MapReduce task that goes out to Couchbase and says, give me data. And there's one of those on each, or more than one. There's at least one of those on a set of nodes. Well, you line up your Couchbase nodes and your Hadoop nodes, and you get this just massive aggregate pipe of data flowing across your network, making your switches cry. And Matt has, I'll make you tell your story when you get up to do the demo, but I'll tell your story about the watching all your little dials move when you lined up the, what'd you have, 24 node clusters?
Oh, yeah. An 18 node cluster and a 21 node cluster, so.
Yeah, so, and just letting them tear, and you can just see the data transfer rates were just insane. All right. So the other thing, and my next slide looked different on here. Okay, good. So the other thing that we're doing is Oozie. So Oozie is a workflow orchestration tool, and that's really all one needs to say about it. It's kind of an XML-based system where you lay out documents that say, this is the things that I want to do. What's interesting about Oozie is it is both orchestration and coordination, so it's workflow and coordination. Right? So not only can you say, this is my chain of events including branching, you can say, and go execute that every Tuesday at 4 o'clock. Right? So you can, in one tool, kind of set up this whole life cycle that Matt had on his use case slides. And then how do you deal with the data? How do you do the analytics? How do you summarize it? It's up to you. Right? Hadoop lets you do it in lots of different ways. Hive, I already mentioned, it's more or less an SQL interface to MapReduce. It's a layer that translates something that looks a lot like SQL into MapReduce jobs for you. So you can say select star from whatever, where, whatever, group by whatever, and then that becomes MapReduce jobs that goes off and runs for you. Pig is a more procedural sort of thing. So if you've ever done, command line data science, cat whatever, pipe grep, pipe cut dash F dash D, right? That's kind of the flow that Pig gives you. And Mahout, like I said, machine learning algorithms prepackaged for you. They're mostly around advertising and online retail. So like doing k-means or doing recommendations or clustering and whatever. Those are the algorithms that are best beefed out. And then MapReduce. Right? So MapReduce is the power tool that fits every purpose, but you have to write code. Right? So the other three above it there let you get away without writing code. MapReduce, you can do anything you want, as long as you're going to write the code for it. So with that, I'm going to let Matt come up and actually show some command line stuff running around.
Sure. So now's the fun part where we actually move some data. So let me do a little bit of setup here. So what I have in this particular case, as Daniel mentioned, we have a 2-node cluster. This happens to be a Couchbase Server 2.0 cluster. Oops. Oh, there it is. Okay. So that's reasonably legible. I'm going to kick off a couple jobs. This is really just going to start simulating an advertising workload. So it's going to simulate a number of users who have, in the ad targeting world, I think this is a common term, server-side cookie, which basically means the cookies got too big to keep shipping down to the clients all the time. So instead you keep a small identifier that's moving back and forth with the user. Maybe it's not even cookie-based, but you keep the profile in what they typically call a server-side cookie. So I'm just kicking off a little bit of workload. This is actually for those, just out of curiosity, how many have downloaded 2.0 already? Okay, that's pretty good. That's pretty good. Okay, so for those who haven't, just couchbase.com/download. It should be a pretty straightforward way to get it. Okay, here comes our workload. And in this particular case, I have a 2-node cluster, two nodes of Linux, and then we also have a 2-node Hadoop cluster. But if I were to grow this cluster from 2 nodes to 3 nodes, I actually wouldn't even need to change anything with my workflow or the way Oozie is going to execute the workflow. So I have a couple different buckets on this system. Oh, actually, I think I have only one bucket. I have the default bucket on this particular system. So the way this workflow works, it's first it creates all the users, and then it starts generating event data. So this event data is going to start ramping up. The events are hitting a number of different users, so I actually picked employee names and added some numbers to the back of it. So, oops.
We're going to be in the lounge just a little bit later.
So we're scheduled to be in the lounge in 15 minutes. So while the no, really,
we are really going to be in the lounge. Trust us.
So while that workload's ramping up, let's take a look at what it takes to move some data from one to the other. Let's see, did we? So for those who who've used, I'm just going to should I just RM it, I guess, first.
Yeah, kill out what's there.
So I'm going to. All I'm going to do is blow away the data from a previous demo just in case it was there. Oh, sure enough, it was there. And I'm going to run a scoop.
Not that one.
No, apparently I'm not.
Well, here, I can tell you the syntax. Scoop import, right?
Yeah, scoop import, and dash table is dump.
I think it's dash table.
Dash table.
And dash connect. Yeah.
10.3.2.35, I think.
Yep.
35's, let me verify that, otherwise, no, 37 and 39. 35 is...
Oh yeah, 35's Hadoop. Yep.
I thought you could tell me.
These are your virtual machines, and dash M2.
Dash M2. So we'll talk through this in a moment. Yeah. That's complete, though, I think. And so, Scoop will tell us in a moment. Okay. Yep. So effectively what's happening right now is prior to this, the Couchbase connector was installed, and the Scoop tool has just a set of command line options, and we've told it to go get everything from a particular Couchbase cluster. If I could specify a particular bucket by doing authentication against that cluster. In this case, I didn't specify anything, so it just went ahead to the default bucket. It connects to that one, and then the dash M2 says I want to split it in 2 ways. Since I have a 2-node cluster, no real reason to split it in more than 2. Yeah.
Scoop defaults, I forget if it's 4 or 8 nodes, but we try and avoid that DOS aspect of Scoop, so we defaulted to either 4 or 8. So in this case, we have 2 nodes, so dash M2. If you wanted to do the DOS, dash 128 or dash M128 is pretty good.
Yeah, and remember I talked about Scoop in Hadoop as being heavy lifting analytics. So it does take a little while for it to get going, but while this is running, I still have a nice, simple, easy workflow across that cluster. About 1,000 ops a second. I'm not really stressing the cluster out, but it's just happily cruising along. And what we should see at some point is the tap queues. Yep, sure enough, we have 2 tap senders. So Scoop actually uses tap to extract data from the cluster. So it's using the same underlying protocol that we use for replication. We're now extracting the data from the cluster and putting it over into the Hadoop cluster. So we're at 50%. I know we went very quickly from 0 to 50%. That's just because one of the 2 jobs is completed.
Exactly.
So shortly we'll see the second job complete. Now the neat thing is, if I were to blow each of these up into, say, a 100-node cluster of Hadoop or a 100-node cluster of Couchbase, the system would just, I could obviously do a -M100, or if I just take the defaults, it'll just split that up into a large number of jobs across the 2. So if you're already familiar with the vBuckets in Couchbase, what it'll do is each MapReduce task will target a certain number of vBuckets based on how it's split. So the story we were talking about earlier, this also sort of predates Scoop, but for those who don't know, I worked on the first version of Northscale Memcached server, the UI, and so much of the UI code is still the same things that we'd written way back then. And I remember when we were doing the ops per second, you have to say, okay, we're going to divide that up by, we'll have thousands of ops a second, millions of ops, billions of ops, and I'm like, yeah, this is a lot of ops. I wonder when I'll see this. Sure enough, in the last 8 months, I saw 13 million ops a second coming out of a Hadoop cluster going into a Couchbase cluster. So the system certainly copes with that kind of work. And so sure enough, we still have our front-end traffic happening at the same time.
So what did you do to my cluster?
Because it's not
it's
completing
not responding.
yet. Oh,
so we could go dig into this, but this is probably not a good time for an online.
Well, you know
exercise.
what's actually changed is that ever since we started running this, each time I run one of those workloads, I'm creating more records. Let's see how many records we have.
I'm guessing what happened there is we've got 2 very unbalanced mappers. One pulled over very little, and the other's pulling over everything else.
Well, we do have a Couchbase cluster that has, what, 1.2 million data items now, where I think when we were first doing these, there would be like 10,000 or so.
Yeah. So if you want to, while that's completing, I can make you type in the Oozie command line so you can see how to launch the Oozie workflow. Or we could just go talk about, look at the Oozie, look at the Scoop, because there were a couple more slides on that.
Should we pop over the slides?
Yeah,
okay.
why don't we slip to the slides? That's probably the most sense.
Okay, I'll turn it back over to you, Daniel.
All right, so we're just going to look at a little bit of what Matt just did there, right? So this has been Matt's cheat sheet. How do you remember to scoop this stuff in? Scoop has kind of a little bit of a thorny interface. It's not bad. Honestly, with Couch, it's beautiful. If you go look at like connecting to MySQL, it makes you weep a little. That's getting better. Next version of Scoop, so Scoop Next Generation, actually has a web UI. And so you can just go into a pretty web page. I would have had screenshots for you, but they haven't built it yet. So I thought of making up something fanciful with unicorns, but I didn't think that would work. All right, so, Couch has these various, let's call them keywords defined for what you can call a table, right? So I guess going back a little bit into history, right? Scoop was designed originally for, as Matt said, RDBMSs. And so the Scoop framework says things like, so tell me which table you'd like to extract from, and please give me your results as a row set. And Couchbase goes, what? Right? So they've, and my stuff's jumping around on me. In Couchbase land, they've kind of overloaded some of these meanings, like table is not a table name. It's a keyword to tell you how you want to behave. Right? Scoop 2.0 fixes that. Right? Scoop actually, considering most of our connectors at this point are NoSQL, it kind of makes sense that we're defocusing on the RDBMS stuff. All right, so Oozie, and this is the workflow that we ran. Or that we didn't run, that I was going to have him run, and then we decided to look at the slides instead because I figured it'd be more exciting than watching him type the command line. This is an XML document that says, and it's kind of neat the way it's structured, right? It says start with the scoop in task, all right? So here's the scoop in action. I'm going to do this stuff. Here's my job tracker, here's my name node, here's what I want to smash before I run, right? You remember first thing Matt did was delete the dump directory. That tells it what path to delete just in case, so you make sure that it goes away. And then here's the scoop command. What we've done here is we've parameterized a lot of this. Remember that connect string? Now it's this variable that we're going to fill in when we run it. That makes it a lot easier to run the command. And then what's neat is you can now branch. Okay, so this is the end of the scoop action. If it was okay, go analyze. If it wasn't okay, go do cleanup. Right? And then you've got, here's the action for analyze, and the analyze action is going to have some end stuff. Right? Everybody's eventually going to culminate with this end. Right? So that's kind of Oozie in action. All right, Matt, you want to go back and see if it's
sure.
See if it's done yet, and if not, we'll just jump to questions.
Question for me actually is, so I could actually tell that Oozie workflow to just keep running every time, right? One after another, and so each time it completes, I would be able to see, I'd just be able to go ahead and run again. In this particular case,
it doesn't need to run in a loop because it's not finishing.
Something has gone awry. So let's go. We'll go ahead and restart that.
Oh, running another one.
Oh, this is going to fail.
Yeah.
Delete dump.
Well, no, it won't so much fail, but now you're going to have two of them banging on your...
Well, but I got to get rid of that.
Or your dump directory.
Yeah.
Well, now the other one's going to... This is interesting. This is going to be fun. So in any case...
we'll have to check into what
that scoop, it generates a lot of output.
Yeah. Beginning dump. We'll go ahead and let that run for a moment.
We'll let that run while we take questions, unless you had another slide you wanted to cover.
Question is this something you would tend to run all the time, or is it batch kind of incremental? Honestly, from what I've seen, most people tend to start with something like daily, and then their requirements tend to grow, and then they start to get to 4 hours or something like that, or a couple times a day, and then after that they start to get to an hour, and then before long they start doing even more quote-unquote real time, right? So I believe that's the pattern I've seen over the course of time. So that's a good question. Actually, that sort of wasn't covered on this particular slide. There is an example here of what is called a backfill. And the interesting thing about backfill is actually sampling. So in some cases, you don't really need all of the data. You just want to see what's currently going on. So in the case of backfill, that means do a 5-minute sampling window, and maybe that's enough profile information. In the case of TAP, we don't really have a way to say go to a particular point in time, so it is either a full dump or it's this sampling approach. We are looking into, can we say from a point in time? Of course, that gets kind of challenging because point in time means that maybe we need to write markers in the files, things of that nature. Another question, yep. I think I knew this question would likely come up. I probably should have proactively addressed it. So to repeat the question, Couchbase has MapReduce. Hadoop is MapReduce with lots of other tools. Why would I use one versus the other? How do the two fit in together? And most of it goes back to what we were talking about earlier, kind of traditional. If you went back 10, 15 years, you'd have a database that was set up for OLTP, the layout and so forth, and then you'd have a database frequently that was set up for decision support systems, DSS. In the modern era, now we have much larger data sets, but the systems still need to be kind of tuned for one or the other in most cases. Couchbase is highly optimized for that really low latency, and part of that is that the MapReduce, as part of the views, is optimized to be able to do incremental MapReduce, meaning that we just rerun the mappers and the reduce logic for only the subset of documents that have changed. Hadoop, on the other hand, doesn't really track specific sets, so you may take different sets of summary and you may have new data, but you always run that MapReduce logic across it, and then frequently you chain those together. On the other hand, it's comparatively difficult to do that sort of chaining in something like Couchbase. So the two, while both are based on this MapReduce sort of programming model, the way that you approach one versus the other is actually slightly different. So I'll come back to questions here in a moment, and we'll, just to repeat it, we will be in the lounge to show you what's going on, and it looks like, yet again, only one of our two guys ran here.
That's because one of them's drowning in data, I'm certain.
Okay. So, but I do, and we're supposed to stop here in just a second, so I just want to do a Hadoop, FS, and then it's just an LS dump, and we should have one of the two there, right?
Yeah, one of them will be there.
And sure enough, we have a part M, and so there's a Hadoop cat,
FS
dash cat, or dash text. Which one's better here?
Okay. Whichever.
Dump part dash M dash
00041. Oh yeah.
And just to let's pipe that to something so that we can make sense of it. Oh wait, I should have piped it to more. Okay. But sure enough, there are all
more or
those
less.
JSON events that had streamed through the system. Or if I want to get, you could just, yeah, I guess we don't need less.
Less is more.
So we'll let that run. And with that, I want to say thank you very much. If you have other questions, please join us up here at the front or come up to the lounge.
Did we mention we'll be in the lounge? Yeah, okay.
Thanks.